हेलो। आप चैट में लिख लीजिए, आपका आवाज क्लियर नहीं है। और कौन सा क्लास है? हाँ, पी एंड एन पी वो इसके बाद होगा। ठीक है, ये होगा, उसके बाद मैं वो न्यूमेरिकल्स कराऊंगी। देन आफ्टर पी एंड एनपी क्लासेस के बारे में जो मैं बताना चाह रही थी ना, वो ये कॉम्प्लेक्सिटी, थ्योरी ऑफ कॉम्प्लेक्सिटी। ठीक है। इसके पॉइंट्स मैं बोर्ड पे ही नोट डाउन कर लेती हूँ, ट्यूरिंग मशीन के। ठीक है, तो आप वहीं से नोट डाउन करिए। Bishan, just now I started the class, okay? So today's first topic is Turing machine, and I'm writing some points on board. The same you note down in your notebook, then I'll explain these points, okay?
Yes, ma'am.
Written this much? Then write down which is, further continue, which is divided into cell, which is divided into cell where each cell is capable of holding one symbol. Where each cell is capable of holding one symbol. Capable of holding one symbol. Next. Right. So this is basically what are the points you should be aware regarding the Turing machine. Then I'll give you the proper what is a Turing machine. Write down. A Turing machine is an automation. A Turing machine is an automation whose temporary storage is a tape. Whose temporary storage is a tape. This tape is divided into cell. This tape is, अच्छा ये तो point लिख लिया ना मैंने. अरे just a second, then don't write this point. This way I've written ना. Right, okay. Then remove this one. Continue with this point. Associated with the tape is a read-write. Associated with the tape is the read-write which can travel right or left. Which can travel right or left on the tape. That can read and write. That can read and write a single symbol. That can read and write single symbol on each move. Okay, so that means on each move you can read or write only the single symbol. It is not possible that at the one time only you are writing 3A. Okay, but remember the memory of Turing machine is infinite. Like I said, no, the regular grammar, there is no memory. Just a second. So for that one regular, there is no memory. For context free, we have only one memory. So a to the power n, b to the power n is accepted. Then context sensitive, a to the power n, b to the power n, c to the power n. That means it has a two comparison. But what is this one Turing machine? It has an unlimited, unrestricted memory. As well as if you see the regular machine, what we are doing? That means in that one, in linear bounded automata and all, you cannot move in both the direction. But in Turing machine, like in push down automata, you can move like in one direction only. But here you have the advantages of moving both the direction, unrestricted. Either you can want, read or write. Both you can perform. Okay? Now, I'll give you the proper definition. Then I'll explain how to construct the Turing machine. So write down definition. The mathematical symbol. The mathematical symbol that computes. The mathematical symbol that compute every logical problem. A mathematical symbol that compute every logical problem is called as Turing machine. Is called as Turing machine. It is represented by 7 tuples. It is represented by 7 tuples. So write down this. This is tau symbol. Huh? Then this capital B here. This is for blank. Then this is your transition symbol. Then your initial and final. Initial and final. Okay. And here I down Q, the first one, set of all states, sigma, set of input output symbols. Okay, first write down this. Okay, now write down Q, set of all states, sigma, set of input output symbol, set of input output symbol. Tau, set of all tape symbols. Tau, set of all tape symbols. Capital B, black symbol, blank symbol, BLNK, blank symbol. Okay, then next the transition function. Transition function I'm writing. Transition function is equals to seven to 8:30, no, 1.5 hour. So 6:30 to, just a second, 6:30 to 7:30 to 8. I was writing transition function now. Q into tau equals to Q into tau into in bracket L comma R bracket close. Okay, so this is the transition function. Okay, now see how if I'll give the example of this transition function, like, so the transition function Q naught initial state, Q naught for A, okay, where it will go, Q naught for A, it will go to, for example, any other state. If I'll give example, Q naught for A, it is going to Q1, right? Then after, what is this X here? X tau function, what is the tau function? What explanation I have given for the tau function? The tape symbol. Okay, so then next what you will write here, we'll write here the tape symbol. Suppose I want to make that A as tape X. So this is the tape symbol, and then after where you want to go, left or right? Suppose I want to move right. So I'll make it as. So like this, actually we'll write this transition function for Turing machine. Okay, and then write down Q naught is an initial state and capital F is a final state, final state. Okay, make some note. Okay, before that, in the Turing machine, in the beginning, I have written one word. It is an abstract model of real computer. Underline that line. It's an important line. It is an abstract model of real computer. Underline that line. Okay, then write down next point. In general, Turing machine is a deterministic model. See, remember this theory points I'll show you. In every year, previous year GATE question paper, there is one question of Turing machine. Okay, next we are going to solve. So that's why remember this point. In general, Turing machine model. In general, Turing machine is a deterministic model. Okay, next machine consists of following components. Turing machine consists of following components. First, infinite tape. Okay, first is infinite tape, second read-write header, and third finite control unit. Okay, so every Turing machine consists of these three components. Will be one infinite tape, there will be one read-write header, and there will be control unit. Okay, infinite tape you understood. Even read-write head, that will, whether you want to move left side or right side, for that we have read-write head. But what is this finite control unit? Okay, so write down. Finite control unit take the input symbol given by header. So whatever the input symbol, that will be taken by this one. Okay, so it takes input symbol given by the header, implements movement of Turing machine, and complete the process of string. Turing machine and complete the process of string. Okay. So that's all we do. Okay, these are also the points you have to make. No? Okay, next make some note. Okay, before making the note, write down halt. What is halt? Because when you place it, you will see this HALT halt. Okay, so I'm giving you first of all, what is this halt? HALT halt. Okay, write down the definition of halt first. The state where the transition is not defined, the state where the transition is not defined for any input output symbol. The state where the transition is not defined for any input output symbol is called halt. Is called halt. Halt can be final or non-final. Halt can be final or non-final. Full stop. Continue. No transaction is allowed at final halt. No transition is allowed at final halt. Even loop is also not allowed. Right? That means if you have a halt at last, even the loop is also not allowed. Okay. Now make some points. Once the Turing machine is started, once the Turing machine starts, and it will continue the execution. Once the Turing machine starts, and it will continue the execution till the string is completely scanned. Till the string is completely scanned. If the string is valid, then it will read complete string. If the string is valid, then it will read complete string and reaches the final halt. If the string is valid, then it will read complete string and reaches the final. अरे वन थिंग आयुष्मान, आप यहाँ आपने बैंगलोर से किया है 12th स्टैंडर्ड भी? आयुष्मान ने नहीं किया, शायद इंजीनियरिंग ही की है. Bishan, you did your 12th from Bangalore only?
Yes, ma'am.
Hey, when does the 12th standard student have final exam? Which month?
My PU exam was on March and April.
Like March ending.
Yes, ma'am. March ending and April.
Okay, so
Or little bit early.
okay, that means in the beginning of March is also possible.
Yes, ma'am. Feb into April first week.
Okay, then it's the December, January, 2 months only. Okay, okay. Next, if the string is invalid, if the string is invalid, then the Turing machine may hold, if the string is invalid, then the Turing machine may halt in some non-final state, or run forever. In bracket, that means loop. Okay, so it may halt in some non-final state or it may go to the looping. Okay, now I'll explain you how to write the basic, how to draw the Turing machine diagram for a simple thing. Okay, just a second. Now see, suppose you want to design the Turing machine for this language. A to the power n, b to the power n, right, where your n is greater than is equals to 1. Where your n is greater than or is equals to 1. Right. So this is one. How to design the Turing machine for this one. Okay. Now here, before we'll start, we have to draw first of all the tape. So see, draw the tape first. Try to understand this one. If you'll understand this example, that means it will be easy for you to understand Turing machine. Ayushman, you joined 3 accounts?
मैम पता नहीं यहाँ नेटवर्क का इशू था तो एक बार लैपटॉप से किया फिर एक और बार किया फिर अभी मोबाइल से कर रहा हूँ।
अब ठीक है, अब आवाज भी आपका क्लियर आ रहा है?
ओके मैम।
ठीक है। Now say, suppose we want to design the Turing machine for this. Equal number of A, equal number of B. So I'll take 3A and 3B. We want to check whether the string will be accepted by Turing machine or not. Okay, so that for that I'm doing it. Basically, before that, I'll explain you what is the logic behind this. In Turing machine, what happens? There is a, as I said you, what is this FC? Finite control unit. Hai na? There is a finite control unit. So here we have initially the finite control unit. That in short we call it as FC, finite control unit. Okay, FC, which perform your read write, which will perform either read or write whatever operation you want. Okay. Now see here what happens. Initially it will go and it will check. Okay, there is a small a. Okay, that means there is one string a. So what they will do, they will make it as x. Okay, and they'll move further. It's an a only. If more a is there, we will skip. Again a is there, we will skip. Now a different value. Okay, so what we'll do, we'll make it as 1. Okay, and we'll move further. Okay, no need to move further. We found one y, no. Okay, then after we'll go back. Okay, and we'll see. Okay, one more a is there. Now, how much it will go back? It will go back till x. Okay, once from x, it will again start. It will convert it to x. It will again move right. Again, a is there. It will skip. Again, y is there. It will move further. Again, b is there. It will make it as y. Okay, then after it will go back. It will check. Okay, there is one more a. It will go back till the last step. It will make it as x. Okay, it will go move right. Again, right. Again, right. It will make it as y. And then it will say check. Okay, now there is nothing in y and there is nothing in x. So that means it will go to the blank string. Okay, that means this string is accept. Okay, now we'll see how to draw the Turing machine diagram. How to design the Turing machine. Okay, I'll remove this. Huh? Now see, to draw the Turing machine, this initially we'll take it as Q0 and then Q1. So see, first of all, Q0 for A. Okay, what it will do? Q0, when it finds A, it will make it as X. And which direction it will go? Right direction. So we'll make it as right. Okay, then it will go to the next state, that is Q. Okay, then after here, whether you will find any number of A, what you want to move right only. Okay, so I'll make here the self loop of A. If you find A, right? Once you find A, you have made it as X. Now again, if you find A, at that time what you do? No need to do, make it as A only, leave it as A only and move which direction, right? So again, it will move right. Just a second. Huh? One minute. Huh? Then after, so we have to find again one more A. What we will do? We will keep it as A only and we'll move it. Okay. Then whenever we'll find B. Okay. Now the next, this is upside. Huh? This is for this country. Now whenever we'll bracket, right? When we find A, leave it as A only and move. Then after, again, when we find B, okay, so next is for B also. Now, so what will happen, Bishan, when we find B? If we find B, then we will make it Y. Correct, no? So when we find B, we will make it as Y. And in which direction we will move now? We will move now on. Right now we'll move now on right direction. Why? Because still we will check if more are there, any other alphabet. No. Then after it will move to the next step. We'll check to the next step. That is your Q. Then at Q2 state we will make the self loop. In case again if you find A, then what you do, A, leave it as A only and move on left direction. And even if you find here that thing, okay, that is fine. No, if you find A, then move like that. Okay. Even if you find B also, what you will do, you have to move on left hand side. Okay. Then after here we move it left hand side, that is fine. Then again if you find here, then the same thing is going to happen. Now we will move right. When we'll move right, in that case, again, okay, second condition also right here. Right, so that means when we'll find B here, we will make it as Y, okay, and then we will move it as right. Okay. That's it. Okay. So see, when we'll make it as right and we'll move to the right direction, that is the next step. From that we'll go back. Okay. Then after again I want, shall I make a loop here? Ayushman, understanding? Shall I make a loop here?
मैम दोबारा समझा दो, मेरे को तो कुछ भी नहीं आया।
ठीक है, वो आपका क्या नेटवर्क इश्यू था ना?
यस मैम।
अच्छा, हाँ, उसकी वजह से आपको हो रहा होगा। एक सेकंड, देखिए मैं वापस एक्सप्लेन करती हूँ। चलिए इसी में बता देती हूँ, ठीक है, या वापस ड्रॉ भी करूँ?
नहीं मैम, जो है वो ठीक है, ऊपर का पहले आप वो बता दो, फिर अपन ने बी कैसे लिया वो फिर हो
अच्छा,
जाएगा।
ऊपर वाला भी आपको नहीं समझ आया था, एक्स वाई वाला?
नो मैम।
ठीक है, तो वापस से ही कर लेती हूँ, कोई दिक्कत नहीं है। चलिए, क्योंकि इम्पोर्टेंट है, मैं एक ही बताने वाली हूँ, तो उसको तो परफेक्ट होना ही चाहिए आपको, है ना? तो देखिए, राइट, ट्यूरिंग मशीन कैसे वर्क होती है? इनिशियली यहाँ पे आपका फंक्शन काउंटर रहता है, राइट? तो वो क्या करेगा, रीड राइट परफॉर्म करता है। तो जैसे ही उसको सिंगल ए मिलेगा, वो उसको क्या करेगा, उसको एक्स में कन्वर्ट कर देगा, देन वो राइट में जाएगा। फिर उसको वापिस ए मिलेगा, तो वो कुछ भी नहीं करेगा, एक को ए ही रहने देगा, राइट में जाएगा। फिर उसको एक और ए मिलेगा, उसको ए ही देने देगा, राइट में जाएगा। ओके, देन अब यहाँ पे उसको क्या मिल गया, अब यहाँ पे उसको नया वेरिएबल मिल गया। अब जैसे ही उसको यहाँ पे नया वेरिएबल मिला बी, तो उसको क्या करेगा, उसको वो वाई में चेंज करेगा, उसको वो वाई में करेगा। फिर यहाँ से वो कहाँ जाएगा, वापस एल, लेफ्ट में जाएगा। और लेफ्ट में कहाँ तक जाएगा, जब तक कि उसको एक्स नहीं मिलेगा। जैसे ही उसको राइट में एक्स मिलेगा, और राइट में जब वो जाएगा और उसको ए मिल रहा है, तो उसको ए ही रहने देगा और वो लेफ्ट में ही जाता जाएगा। अब जैसे यहाँ पे आपका फंक्शन काउंटर लेफ्ट में गया, उसको ए मिला, तो उसको वाई नहीं करना है, आपको आगे ही जाना, उसको ए रहने देना है, ठीक है? जैसे ही आपको एक्स मिले, वहां से आपको फिर राइट आना है, और जो भी ए हो उसको एक्स करना है, ठीक है? फिर राइट आए, अगेन ए मिला, उसको कुछ नहीं करना है, ऐसे ही रहने दो। फिर यहाँ पे वापस वाई आया, कोई दिक्कत नहीं है, अगेन आगे जाओ। एक और बी मिला वाई के बाद, उसको आप वाई में चेंज करो, ठीक है? देन आप कहाँ जाओ, वापस लेफ्ट जाओ। वापस वाई मिल रहा है, वाई को वाई रहने देना है। वापस आते टाइम आपको स्मॉल ए मिल रहा है, ठीक है, उसको ए ही रहने देना है। वापस आते टाइम आपको जब एक्स मिले, वहां से वापस क्या करोगे आप, राइट। राइट में आपको ए मिला, उसको एक्स बनाओ, ठीक है? फिर वापस राइट में जाओ। राइट में आपको वाई मिलेगा, वाई को वाई रहने देना है। अगेन वाई मिलेगा, वाई को वाई रहने देना है। अगेन आपको मिलेगा बी, तो ये बी भी वाई के बाद है, उसको वाई चेंज करो, ठीक है? और अब यहाँ पे आपको वापस जाके आप चेक कर लेना कि भाई और ए है कि नहीं। यहाँ पे एक भी ए नहीं है, यहाँ पे एक भी बी नहीं बचा। अगर एक भी ए या बी बचा, तो आपकी ये स्ट्रिंग एक्सेप्ट नहीं है, ठीक है? वो वही रुक जाता है। लेकिन यहाँ पे कुछ भी नहीं बचा, तो ये कहाँ चला जाएगा, ब्लैंक में चला जाएगा, और दैट मींस इट विल गो टू द फाइनल।
ओके मैम।
समझ आया कंसेप्ट?
यस मैम।
चलिए, अब मैं इसका पहले मैं पूरा ड्रॉ ही कर लेती हूँ अच्छे से, ठीक है? फिर उसमें एक्सप्लेन करती हूँ। और मैं ड्रॉ कर रही हूँ ना, आप लोग भी साथ में ड्रॉ करते जाओ और समझने की कोशिश करो, ठीक है? Now stop writing. See here, what I explained you, the same thing I did in this design of Turing machine. See, initially we'll start with Q naught. Q naught में क्या हो रहा है? Right. First of all, we'll get an A, so we will make it as X and we'll move right. That means the next transaction. Okay. Then after here if we'll get again A, let it be A only. The middle one, that means the value you want to replace, you want to change. But here I want to make A only. Right. We don't want to replace. Right. So let it be A only. Move right. Then when you get B, what you want? You want to make it as Y. When you get B, make it as Y and move left. I said we have to move left back. Okay. But in left also it will go to new only. In new state also, while going back, if you will find L, and see from here when you will go back, you will find one capital A. Okay, that means let it be Y only and move left. Then while going back, you will find A also, right? Where it is, we have not replaced it with X. So whenever you find A also, let it be A only and move left. Aishwin, understood this much?
Yes, ma'am.
Then after, when we'll go back, now whenever you will find X, so let it be X only and move right. Okay. Then once you will find N, that thing again this loop will go. We will make it as A, B to B and all. Okay, so this loop will go until your all X will change to A will change to X and B will change to Y. Then after, whenever you will complete your all that, so then after Y, let the Y be only and move right. Now, till where we'll go, it is a loop. That means, see, we'll convert this A to X. Then after we'll go, when you will find Y. Okay, then once you are done with all, then when you find a blank, okay, let it be blank only and move right. So it will reach your final stage. So this is the design of a Turing machine. Understood?
हाँ,
Write
ma'am.
out this. लिख लो. Okay. Next is your what we'll say, a transition table. That was a transition diagram. Okay. Next, how to draw the transition table for this for Turing machine. Okay. So see, I'll explain. Initially, this will be the transition. That means the state, and here will be the variables. One, two, three, four, five. No? This is for small a, small b, x, y, and this is for blank b. Okay. Then after here, q0, q0, q1, q2, q3. How many states we have? Q4. So we'll write that all. Okay. Then after q0 for a, where it went, q0 for a, it went to q1. Okay. So we'll write like this. And so here q0 for a, that is a comma capital X comma r. Okay. So q0 for a, it will make it as X and it will move, right? Okay. q0 for b. So we have any option for q0 for b? No. So what we will do, we will make it as hold. Okay, so wherever there is a blank, okay, if you remember, I have given you the definition of hold. Okay, so whenever there is a blank, we'll make it as hold. Then after q0 for x, okay, q0 for x, it doesn't went anywhere. Okay, so we will make it as hold only. Okay, q0 for y, Aishman, q0 for y, it went to q3, right?
Yes, ma'am.
So we'll write here y comma r. Okay, and then q0 for b, it
Hold.
didn't went anywhere, halt. Okay. So I hope you understand. Now you try to complete this. Then after I'll write here also. So you just check whether your is right or wrong. Okay, but see once. Okay, now I'm writing. You can just cross check yours. Q1 on. Q2 for A. Q1 for capital X. That's not going anywhere, no? For capital X, halt only. Q2 for capital X is going on, right? So capital X, comma, right. Q3 for X, halt only. Q4 for X. For Q4 is halt for all. Then after Q1 for Y, Y only. Q1 for Y, let it be Y only and move right. Q1 for B, it's not going anywhere, no, halt. Then Q2 for Y. Q2 for Y, it is going to Y only. Y, comma, till Q2 for capital B. That is also not going anywhere. Hold only. Then Q3 for Y. Q3 for Y. What will do? It's going now. Y for Y only and then B. Y ko Y रहने दो and then move right. Then after Q3 for B. So Q3 for B is going now. So capital B, comma, R. Okay, so it was right, Ayushman? Your Bishan?
Yes, ma'am.
For you, Bishan? Understood?
Yes, ma'am.
Okay.
Yes, ma'am.
Next, okay, good. Next, give heading. Computable language. Next, give heading. Computable languages. The language which is accepted by some Turing machine. The language which is accepted by some Turing machine is called computable languages. The language which is accepted by Turing machine is called computable languages or recursive enumerable language Next line. Computable language is divided into two types. Computation language is divided into two types. Recursive in bracket write decidable. Recursive language in bracket write down decidable. And second one, recursive enumerable language in bracket write down semi-decidable. Semi-decidable. Then give heading recursive language. Just 1 minute. Right? Recursive language. I said, computation language is divided into two types: recursive language and recursive enumerable language. recursive language and recursive enumerable language. Okay, then write down recursive language. Let L is any language, capital L, huh? Let L is any language. Just a second. हेलो सॉरी, हाँ बीच में ब्रेक लेने के लिए थोड़ा सा. हाँ, now write down recursive language. Let capital L, let L is any language accepted by Turing machine. Let capital L is any language accepted by Turing machine, then L is said to be recursive. Then L is said to be recursive if capital M holds on, if capital M holds on, HALTS, holds on every string, if capital L holds on every string. Next line in the recursive language only. The language accepted by Turing machine, the language accepted by Turing machine for which membership property is decidable, for which membership property is decidable, is called recursive language. Please underline this line. The language accepted by Turing machine for which membership property is decidable. Underline this line. Membership property is decidable is called recursive language. Okay. So that means when you can say that Turing machine, that is a recursive language, when the language which is accepted by Turing machine as well as where your membership property is decidable. Where your Membership property is decidable. Okay. Next, give heading recursive enumerable language. There write down. Suppose L is any language accepted by Turing machine M. Suppose L is any language accepted by Turing machine M. Then L is said to be recursive enumerable. Then L is said to be recursive enumerable if capital M holds on, if capital M holds on every, the write of this, every W belongs to L or W belongs to L or W not belongs to L. For all W belongs to L or W not belongs to L. Turing machine M may or may not hold. W does not belongs to L. Turing machine may or may not halt. Next line. Actually, that is a note. Write down. The language capital L is recursive. The language capital L is recursive. See, actually, this Turing machine is very important topic, right? Actually, 100% one question will be there from only Turing machine portion. Okay, and there can be more than one also. So that, and one more, mostly they'll ask this theory points only for Turing machine. So that's why I want you to write each and every point which is important. Okay, so if you will learn, if you will read only my notes, that is more than enough. You don't have to read anything else regarding this Turing machine topic. Okay, no need to read any theory point extra. Either GATE or UGC NET for both. Now write down, the language L is recursive if and only if accepted by DTM. DTM, that means deterministic Turing machine. The language L is recursive if and only if it is accepted by DTM that hold on every input. That HALT hold on every input. Next line. Some of the acceptable languages in bracket recursive enumerable language, that is REL, some acceptable language in bracket REL are recursive languages in bracket decidable. Decidable. Next point. Every recursive language is REL. REL in capital. Every recursive language is REL, but every REL need not be recursive. Vice versa is not possible. But every REL need not be recursive. Next point. If capital L is any language from, if L is any language from, I'm writing yes, 2 to the power sigma star. This is star. Huh? So write down, if any language from, then write down this 2 to the power sigma star. Then, right, so that means if any language which is having this thing, then inside that write down first point, it can be recursive language. It can be recursive language. It can be recursive enumerable but not recursive. It can be recursive enumerable but not recursive. Next point. L can be non-recursive enumerable. L can be non-recursive enumerable. Okay, that's all with this. Next. Now write down closure properties of recursive language. Closure property of recursive language, that I'll write it on board, so that you'll not make a mistake. Yes, which is are closed under recursive language and which is not closed under. Next. It is closed under inverse homomorphism but not homomorphism. Subset. It is closed under even the subset. Sorry, it's not closed under subset. And then substitution. Okay, write down this one. Next one. Closure property of recursive enumerable language, that is RE. Concatenation. Concatenation or intersection. Then reversal. Homomorphism. Inverse homomorphism. Substitution. Intersection with regular cell. And the same only the last one. Quotient with regular. With regular. Sorry. It is not closed under. Not closed under complement. Next, set difference. Complement, set difference. And even it is not closed under subset. So write down this. Next, give heading. Context sensitive language. Next, context sensitive language. The language generated by some context sensitive grammar. The language generated by some context sensitive grammar or accepted by some linear bounded automata or accepted by some linear bounded automata is called context sensitive language. Is called context sensitive language. For example, for another example, so what are the language accepted by context sensitive? As I said, a to the power n, b to the power n is not accepted in regular, it is accepted in context free language. Okay, and if c to the power n, this is not accepted in context free, but it is accepted in context sensitive. So this is also one example. Okay, even okay, I'll give some examples because no, in exam they'll ask us, it will be helpful. Okay, so write down the examples for context sensitive. That means these are all the language accepted by context. Okay, first I've given a write down that a to the power n, b to the power n, c to the power n, and n is greater than is equal to. Okay, the second. A to the power n, b to the power n, c to the power p, where your n is not equals to m, is not equal to. This is accepted by context sensitive. Okay, this one is accepted by context sensitive. Next. In the same only, if I say that my m is greater than or is equals to n is less than is equals to p. If I want like that. So that is also accepted. Next, in the same only, if I say my m is equals to n dot p, that means n multiplied by p, that is also accepted. Yes. Now if I say my language L is equals to a to the power m, b to the power n, where your m is equals to n squared. Okay, so this is also accepted here. Next, a to the power m, p to the power n, c to the power 2, where your m is equals to n into p ka under root square. That is also accepted in context sensitive. Okay. Then one more well-known language, many times they have asked this thing in exam, a to the power p, where p is prime number. So that is also accepted. Where p is prime number. Okay, that is acceptable. Okay. The next language, for example, my L is equals to in curly bracket a to the power 2n. A to the power 2n, where your n is greater than or is equal to 0. That is also accepted. Okay. Next, give heading representation of context sensitive language. Representation of context sensitive language. Write down. Context sensitive language is represented as context free grammar first, second linear bounded automata. Okay, so it can be represented first, context sensitive grammar, second, linear bounded automata. Grammar, linear bounded automata. Okay. Now give heading context sensitive grammar. It is a which type of grammar? Type 1 grammar. Okay, recursive enumerable is type 0. This is your type 1. So write down context sensitive grammar. Inside that write down the grammar G is equals to VTPS, which I already explained you what is V, what is T, what is P, and what is N in last class. Okay. So the grammar G is equals to in curly bracket V, T, P, and S. Is said to be context sensitive. The grammar G is equals to VTPS is said to be context sensitive or context dependent if every production is in the form alpha tends to beta, comma, mode of alpha is less than or equals to mode of beta, where your alpha comma beta belongs to B plus T to the power star. B plus T to the power star. Okay. Now, if you remember what grammar we did in context sensitive and what grammar we did in regular, right? So this thing is not possible there, which is possible here. If you remember, on the left hand side we can have only the single, like small a, capital A, small a, capital S, small a, capital S. Then again, suppose I have S tends to small a, S, A, C. Okay, suppose I have right. Now, if you remember in context sensitive, what we write? We write capital A is equal to like this. Right, but we cannot use small letters. Right, terminus you cannot use on left hand side, but that is possible in this one. Okay, So I can write the grammar like CA tends to AC. I can write it, which is not possible in other grammar. Okay. Then even I can write like this. Even I can write like this. Okay, so that is possible here.
मैम ये किसी को भी किसी से चेंज कर देते हैं?
हाँ, इसमें कोई रेस्ट्रिक्शन नहीं है,
कुछ भी कर दो.
यस, ठीक है. और ये किसकी ग्रामर, इसका लैंग्वेज बता सकते हो आप? चलिए एक काम करिए, डू वन थिंग, ट्राई टू ड्रॉ द ट्री ऑफ दिस वन एंड टेल मी like it is of which language, what string it will generate actually. Give me one example of this string.
ये आपने 2-3 रूल्स दिए इनसे ना?
हाँ. Okay, Bishan, even you have to do. Bishan, draw the tree from this one and give me one string that you will get from this one. So you will get what language it is. In exam, they can ask you, they will give you the grammar and there are 4 options. L is equals to A to the power n, B to the power n. C is equals to A to the power n, B to the power n, C to the power n. D is equals to A to the power 2, like that. Anything they can give. 4 languages are there, right? So how to find that one? Just try.
मैम इसमें B का तो काम ही नहीं है ना?
I don't know anything. Okay, the grammar is this one only. I have checked. It's correct. Okay, just try first. Okay. एक मिनट. What string you will get? Ayushman Bishan.
A power n, C power n.
Then what about B?
मैम B का तो इसमें काम ही नहीं आ रहा है कुछ.
And Bishan, what about you? What string you are getting?
One minute. From A power n, C power n, and B power 2n.
The answer is A to the power n, B to the power n, C to the power also n only. Okay, that's why I'm just let to cross check this. Actually, I have my own language which I can write. Okay, if you want, I can write this. But here also they have given answer as this only. Right? But how they will go to B? Because you need CA to go to AC, right? But here you have AC. You don't have CA. You know? Okay, just tell me then have you moved further here after C?
मैं ऐसी को डालता रहा, मेरे तो बाकी दोनों रूल्स तो काम ही नहीं आए.
Oh no, it's wrong also. Even it means there's not ending also, no? Properly. So I
Yes,
think
ma'am.
there's a problem only. I think. Okay, I'll give you the grammar if you want for that. Okay, so the grammar for that one will be this one. I'm writing the grammar. You just check from that it will get. So S tells to ABC or A, capital A, BC. Second, then I'll get from this option is there. Okay. Then after I can do this thing A to B. If I'll take A to B, I'll get this as B then capital A. Okay, that is also. Then what about C? So AC in case when we'll get so AC tends to BCC. Then after B capital B tends to capital B we should get. Okay. Then after what about if we'll get AB, na? So A then capital B tends to AA/A. I think this will work. Please check once. Just try to generate the language from this one, okay?
Yes, ma'am.
You're getting A to the power n, B to the power n, C to the power n.
Yes, ma'am.
Good. Right. So this is the grammar for that one. Okay. Okay. Now give heading LBA. That is linear bounded automata. For that also I'll give you the points. Linear bounded automata. LBA is a unidirectional tuning machine. Tuning machine is a bidirectional, but if you make the tuning machine as unidirectional, it will become LBA, linear bounded automata. So write down, linear bounded automata is unidirectional tuning machine. Linear bounded automata is unidirectional Turing machine. Linear bounded automata is a non-deterministic Turing machine. Linear bounded automata is a non-deterministic Turing machine. Next line. It has two moves, or you can say linear bounded automata has two moves. Left from the left end marker. Linear bounded automata has two moves. Left from the left end marker and right from the right end marker. Left from the left end marker, end marker, and right from the right end marker. Next point. The language used by linear bounded automata. The language used by linear bounded automata is context sensitive language. Comma, it is free from epsilon. Are you agree with this? It is free from epsilon. So see, I have not used epsilon anywhere. Okay, so whenever the grammar is linear bounded automata, that is a context sensitive grammar. That means it is a free from epsilon. Will not write epsilon there. Clear? Next, every context sensitive language is recursive set. Every context sensitive language is recursive set, but vice versa is not possible. But vice versa is not possible. Next, linear bounded automata has finite number of memory cells. So here also the memory is not infinite. Memory is infinite only in the Turing machine. In linear bounded automata also, it has a many memory but with a finite. So linear bounded automata has finite number of memory cells. Linear bounded automata has finite number of memory cells. Okay, so in short, I'll give you the definition. Write down the main definition for linear bounded automata. The non-deterministic tuning machine, the non-deterministic tuning machine with finite number of memory cells, the non-deterministic Turing machine with finite number of memory cells and that halt on every input string, and that halt on every input string is called linear bounded automata. Okay, next point. Dollar is left marker. Write down. Right, draw this S and then cut. Dollar is left marker, then C and then cut is right marker. Left marker and right marker. Next line. Read write header moves. Read write header moves between left and right markers. Read and write header moves between left and right markers. Between left and right markers. Okay. Next, write down closure property. Closure property for context sensitive language. Closure property for context sensitive language. Write down. It is closed under first complementation. It is closed under complementation, comma union, comma intersection, comma concatenation, next reverse operation, concatenation, comma reverse operation, sixth inverse homomorphism, seventh intersection with regular set, and the eighth and last one Clint closure, KLEENE, Clint closure, KLEENE, Clint closure. Next, context sensitive language is not closed under first substitution. Context sensitive language is not closed under first substitution, second homomorphism. Substitution, second homomorphism. Okay. Then note, write a note. Every context sensitive language is recursive language. Every context sensitive is recursive language, but recursive language need not to be context sensitive. Every context sensitive language is recursive language, but every recursive languages need not be context sensitive. Second note, every property of extended regular expression is recursive. Every property of extended regular expression is recursive, but not context sensitive language, but not CSL. Okay, now I'm drawing one diagram which is very important. Okay? So even you draw this. 1 2 3 4 5 6 1 2 3 4 5 एक और है. Even you can draw like circle, but I have drawn like it's one circle inside another circle. This is REL. In bracket write down recursive enumerable language. REL, that is recursive enumerable language. Inside that REC, that is recursive. If you can't remember the full form, write down. If you can't remember, write down it full only. First, recursive enumerable language. REC, that is a recursive language. CSL, context sensitive language. CFL, context free language. DCFL, deterministic context free language. DCFL, deterministic context free language. And at the last, RL, that is a regular language. Okay, so please remember this diagram is very important. What this diagram means to say, that means whatever the language that is accepted by regular, that is accepted by this one. Okay, so that means, can I say recursive language accept regular language? Yes. Recursive enumerable accept regular because it's inside the circle. But I can't say that regular accept any other of this language. Correct. So I'm asking you, Bishan, can I say that context sensitive language accepted by recursive language? Context sensitive language is accepted by recursive language? Aishman?
Yes, ma'am.
Context sensitive language is accepted by recursive language?
Yes, ma'am.
Bishan, see how to remember this if you are confused with this. For example, if I say this is Karnataka, okay, this circle, this is whole Karnataka. Now, inside Karnataka, suppose if I say this is a Bangalore city, okay, and this is a Karnataka, whole Karnataka. Okay, now suppose if you stay in Bishan in Bangalore, can I say you are staying in Karnataka?
Yes, ma'am.
Correct. So that means if the circle is inside, it is possible. That means if I'm in Bangalore, I'm in Karnataka. But if I have one more circle here, okay, in Karnataka, even Mysore comes, right? So suppose another city is Mysore. Okay, that means, Bishan, if I say that you are staying in Karnataka, that means you are staying in Mysore?
No, ma'am.
Not possible. Understood? So that what? So if
Yes,
I
ma'am.
say context sensitive, that means recursive language is context sensitive? Yes, because this context sensitive is inside recursive. But opposite is not. Pakka
Ma'am, REC
understood?
क्या full form?
Huh?
REC क्या full form है?
Recursive language.
Okay.
REC recursive, REL recursive enumerable language, बाकी तो पता ही है. ठीक है? Next point. Actually, I don't want to miss any single point also. That's why. Make note a point. Universal Turing machine. Universal Turing machine is a generic computer. Universal Turing machine is a generic computer and simulates any Turing machine. Universal Turing machine is a generic computer and simulates any Turing machine. Next point. Universal Turing machine has multitasking capability. Universal Turing machine has multitasking capability. Next point. It will get input. It has three options. When Universal Turing machine will get input, it has three options. First, accept. Second, reject. Or third, move it to the loop. So there are three options. Okay, so when we'll give input to the Universal Turing machine, so either you will get accepted, either it will get rejected, or either it will go to loop.
Either it will go to
loop, LOOP, loop. So decidable and undecidable. Okay, so first I'll tell this one. Okay, then we'll solve the questions, right? That is better. Now next heading, theory of undecidability. Topic name is theory of undecidability. Inside that, write down first point, decidable language. Basically, there are two types of language, decidable and undecidable. Decidable, that means you can decide whether it will give output or not. Okay, and the language which you are not sure, you are not able to decide, that is an undecidable. Okay, but I'll give definition. Write down decidable language. Decidable language. The language L is said to be decidable. The language L is said to be decidable. Is said to be decidable if there exists a deterministic Turing machine. If there exists a deterministic Turing machine that accept every string of L. That accept every string of L, that is capital L, no? That accept every string of L and reject every string of L1. That reject every string of L1. Next note, write down most important notes. Okay, it's very important. Every recursive language is decidable. Every recursive language is decidable. Second point, every regular language is decidable. Every recursive language is decidable. Second, every regular language is decidable. Next, every context-free language is decidable. Next, every context-sensitive language is decidable. Every context-sensitive language is decidable. Every context-sensitive language is decidable. Okay, next write down undecidable language. The language L is said to be undecidable. The language L is said to be undecidable if it is not accepted by, if it is not accepted by, if it is not accepted by any deterministic Turing machine, if it is not accepted by every determinist, if it's not accepted by any deterministic Turing machine, the halt on every input. The halt on every input. The halt on every input. Okay, so that is an undecidable language. Next. Okay, now you want a break? Then after I'll give you one chart, and based on that we are going to solve many questions. Right? So you need a break, so I'll give you a break. Otherwise, we'll move with the next portion chart.
Ma'am, break.
Break, no? So right now it's 2:30. 15 minutes is fine, or 10 minutes is fine?
Yes, ma'am. 15 minutes, fine.
50. Okay. So right now the timing is at 2:30. So we'll start at 2:45. Okay?
Yes, ma'am.
Okay. Okay. Now see, Aishman, actually now we have to write this separate for all. Okay. But no need. In my book, I have created one table. Okay. So if you know this table, you can answer all these questions. Okay. So that's why I'm drawing this table. It's very important. Huh? So recursive interpretable language, that is Turing machine. Huh? REC, that is recursive. Then context sensitive language, CSL. CSL. Next, CFL, contextual language. Then DCFL, deterministic contextual language. Okay, what you will give heading? It is basically my shortcut tricks for decidable and undecidable. Okay, so give heading decidable and undecidable languages. Right. Deterministic contextual language, and the last one is regular. RL, that is regular language. Okay. The next, the problems. These are the problem. First one is is W. This means epsilon. Huh? WEL. That means W belongs to, sorry, epsilon. Yeah, just a second. That means is W belongs to L? Question mark. Okay, is W belongs to L? This is known as membership problem. Okay, this problem is what? Right. If you want to check whether your W belongs to the language, specific language, right? If you want to check, so that is known as basically membership problem. Okay, so this is your membership problem. And membership problem is decidable for all, only recursive enumerable it is undecidable. Rest all it is decidable. D means decidable, UD that means undecidable. So it is decidable for this one also, this also, this also. That means if we will see the language, no, if we'll see the strings and all, we can recognize, okay, this is the language, right? But in this one Turing machine, right, you cannot recognize perfectly. You can't say that it's pakka like that only. So that is undecided. Okay. Next. Second is capital L belongs to phi. Phi that means empty. Okay, belongs to phi empty. This is known as what? Emptiness problem. This is known as emptiness problem. decidable for recursive. Sorry, regular, decidable for this one, decidable for this one, and it's undecidable for the remaining. Then third, write down, is L is equals to finite or not? Question mark. Is L is equals to finite or not? Okay, if you want to check that one, question mark. So this problem is known as actually finiteness problem. Okay, so finiteness problem is actually decidable, same only. Decidable in this one and decidable is undecidable. So decidable D, and it is undecidable for this. UD. You have to create your own trick and learn this. Huh? Next, fourth one. Is L1 is equals to L2? Right, if you want to check whether these two languages are equivalent. Okay, so it is known as equivalence problem. Equivalence problem, right? So equivalence problem is only decidable in regular, correct? No, in regular only we did the question like this, both languages are equivalent or not. We have not did it anywhere else. So it is decidable only in the regular language. Other than that, it's an undecidable for all. Fifth is L1 caret L2, that means intersection, is L1 just a second. Is L1 caret L2 is equals to 5. Is L1 caret L2 is equals to 5. So write down, this is known as intersection empty problem. Intersection empty problem. And this is also same, decidable for this one and remaining all undecidable. Written this much, shall I erase this all? Bishan written?
Yes, ma'am.
We till 6th, till 5th, next 6th. Total we have 12. Huh? 6th one is sigma star. is a sigma star, that is question mark. Okay, this is what this problem is known as totality or completeness problem. This is known as completeness problem.
मैम ये क्या क्वेश्चन मार्क है?
हाँ पीछे क्वेश्चन मार्क. क्वेश्चन मार्क है, इसको बोलते हैं कंप्लीटनेस प्रॉब्लम या टोटलिटी. और इसका बोले कहाँ पे डिसाइडेबल और अनडिसाइडेबल है, तो दिस इज डिसाइडेबल फॉर द फर्स्ट टू. Decidable, decidable, and remaining all it is an undecidable. Seventh is L1 subset of L2. This is a subset, थोड़ा लंबा करना उसको. Is L1 subset of L2? This is known as subset problem. Is L1 subset of L2? And this one is decidable only for the first one. Decidable and remaining all undecidable. Eighth is L1 intersection L2. Sorry, if L1 caret L2 is equals to finite, is equals to finite. This is known as co-finiteness problem. Co-finiteness problem. It is decidable for only first. Okay. See, co-finiteness problem. This is known as co-finiteness problem. Even one more, like I'll hiding it as 9 only. That is also a co-finiteness problem only. That is what is my sigma star minus L is equals to finite. Write down. Is my sigma star minus L is equals to finite question mark, and write down below. This is also known as co-finiteness problem, and this is also same. DD, then UD. This row is also same. Okay, write down the 9th one. Written? Okay, then I'm erasing this one, huh? Then we'll write next one. We did till 9th one, no? Then 10th. L is equals to regular. Okay, so whatever grammar they have given, right, whatever language they have, is L is equals to regular actually. यहाँ पे is दिया है, is L is equals to regular. Okay, so for that one, this is known as regularity problem. Okay, regularity problem, and regularity problem is decidable for first two. Decidable and decidable. Okay, remaining all is undecided. Next, 11th one, ambiguity problem. This is also very important. Ambiguity problem. Right, ambiguity problem is decidable only the first. Rest all is undecidable. Just a second, I'm right. Ambiguity. Undecidable. And the last one, the 12th, is complement of language is of same type or not? Is complement of language is complement of language is of same type or not? Okay, so this one is decidable by this one, undecidable by this one, decidable by this one, decidable, and then remaining two are also. No, just a second. First two, just a second, it's wrong. Sorry. Decidable, then this one is decidable, then one undecidable, then decidable, and undecidable. Well, that's all with this. Any question? No, no?
No, ma'am.
Okay, now I'm forwarding the questions one by one. You answer fastly, okay? Just see, this type of question will come in exam, in GATE. Okay, even in GATE also they'll ask theory questions like this. I'm forwarding. Where is that group?